Hello, so I'm going to be talking to you about a surface development question. This is the question that the students are given. It's an adaptation from a question and answers book. In the book, you have to develop all the surfaces. Just for this question, I've said to the students they develop just surface A and B. I'll go back to my model space. This is the question I've developed it from. There's actually a mistake on this question. This line here is along our surface B, and our surface B is an inclined surface, and because our transition piece is at 45 degrees, that's what's making this line at 45 degrees. However, due to the inclination of this plane, the line won't actually, or the plan view of our transition piece won't be a rectangle. It'll be taken down to a four-sided shape, and we go down and slope this way. To find them points, we have to use an end view, bring the points across to where point here 8 and 7 are going to hit off this back edge. I can just show you how I did that. Find my points here. So that was the first part of the question. You have to actually be able to draw the elevation plan and end view. We didn't specify to draw an end view, but you need the end view to find your plan. So students are asked to develop the true shape of surface A and B. So what I've done was I've decided to use the rebatement method for this. Now you could equally use the cone and use a cone to find true lengths, and use triangulation then to find your surfaces. Just because we're developing only surface A and B, it was just very easy to use rebatement. So the students should understand that in elevation we're able to see surface A as an edge view, and an edge view always gives us a true length, or a true length of a line. So what we can say is we're hinging. We can explain to students and say we're hinging surface A around this point here and folding it down flat onto our horizontal plane, or our XY. We can project that down and bring out our points, and that'll give us our true shape of surface A. The model that we made previously, the little cardboard model with the piece of paper folding down as a surface, would be ideal to help teach the students about this principle. We come over here then and we develop surface B. Now originally some students may say we have the true length of this line, that means we also have the true length of it here for surface B. However, that's not necessarily true. Although they share the same point, surface A is at a steeper slope than surface B, and that means it's technically traveling a further distance to get to the same height. So students will have to come to their end view, fold down surface B flat to get their heights, and then reference it back off the plan, project them back down, and draw in our true shape. That's one very important principle that students should be able to realize, that surface A and B are two different slopes, meaning that although they share the same axis, and it is a generator of what they could think of as one cone, it's actually two different cones. It's a generator where two cones are intersecting. But that may be a little bit complicated, and to explain that you might have to use a sketch to further explain that. Thank you very much.